Welcome to 7-2 of chapters of sequences and series. This is going to be on the arithmetic sequence. And what it is, I already wrote the definition, is a sequence in which the difference between any two consecutive terms is constant. Oh boy, so what that means is, let's erase this, is say for example between 29 and 37, the difference is 8. The difference between 37 and 45, 8. 45 and 53, 8, so on, so on, so on. So the difference between two consecutive constants, two consecutive terms, is the same constant, which is 8. There we go. That's where we know it's an arithmetic sequence. And what we call that difference is D. So in this case, D is going to be 8. And we can figure out every term after that pretty easily. Let's start our braces. We get after 61, we get 69, 77, 85, 93. There we go. It says to find the next four terms, and we did that. So here we go. Number 3. We know this is going to be an arithmetic sequence because that's the name of this section. So we are using our brains here. 25 to 11, that is going to be negative 14. And I assume it's going to be the same because we're doing arithmetic sequences. Let's see if my assumption's correct. 11 to negative 3, negative 14. And I'm sure it's going to be the same. So what's our D? Negative 14. There we go. And we can solve everything after that. Negative 31 will be negative 45. And then negative 59, negative 73, negative 87. Boom. Done. And then we would do that for 2 and 4 and find our D. Now, we talked about the arithmetic sequence formula in the last section. I'm going to explain it in more detail today, but here it is formalized. And A1 is going to be the first term, D is going to be the common difference. So I'm going to explain what the heck this means. So here it is. I'm going to cut it. And move it down here. No, what happened? Come on. Come on. There we go. Let's make it smaller. Boop. All right, so here we go. What it means is, say for example, we're using number 5 here. The first term we know is 7. So A1 equals 7. We then got to see, is this arithmetic sequence? It is. Going up by 6, going up by 6, going up by 6, which means our D is going to be 6. So say, for example, I had 7, and I wanted to figure out the 5th term away. Let's rewind. I want to explain it in a little different way. So say I'm doing, 2 times, let's say I'm doing 2 times 8. What 2 times 8 is 2 plus 2 plus 2 plus 2, 4, 5, 6, 7, 8. So it's adding 8. So it's adding 2 8 times. So what I could do is I take my first 2, so that would be my first term, and then I take the other terms. Instead of writing it as 2 plus 2 7 times, I know the next 7 terms are going to be multiplied by 2. So because I 2, and the next is going to be 7 times. That's the difference, 2. In this case, and then how many terms I had to multiply by are 7. So that's where the n minus 1 comes in. So say for example, I start with 7, right? There's going to be whatever amount comes next, so it's going to be 6 times whatever will give us the next number. So say we want 19. That's going to be 2 terms away. So it's going to be 7 plus 6 times 2. And does that work out? It does. So if we're going 3 terms away, 7 plus 6 times 3. That's going to be 25. It works every time. So that's basically all we're doing. We're turning into a multiplication problem, adding to the first term. So the difference times whatever is going to give us how many points away we are going, basically. How many, as we call it, terms away. So here we go. Let's put it into a nice fashion here. All right, let's go purple again. So we got our first term again, 7. We got our D, which is 6. So we set it up. We go A of n equals our first term plus, and without doing the formula, we can kind of do this. It's going to be 6 times how many terms away we're going to be. So if we're going general, it would be n minus 1 terms. So say, for example, it was n7 we're trying to find. Then we would go our first term plus 6 times 6 terms. Right? That makes sense. And then if we're going a to 32nd, we're going to go 7 plus 6 times 31. That would make sense. The 6 times 31 is going to be the sum of the rest, because we're going 6 plus 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 7. All right? So that answer is going to be, I'm not sure. I'd have to do that out. 6 times 31 is going to be 186, I believe. Let me do that out. Yeah, well, the answer is going to end up being 193. Yeah, 193. And there we go. It's not too bad then. So let's do number 7. We're looking for A45. But first, we know our first term is going to be negative 23. And then the difference is going to be, we are not subtracting 4, but adding 4. Adding 4, adding 4. So if we had the first term, negative 23, we can find the rest by doing 4, and we add it onto it. Say we're going 5 terms away. 5 terms away from 23. That would be times 5. And we can find out what our value is going to be. Okay? So we have our D being 4. So setting it up is pretty easy, actually. Negative 23. But I just want you to understand it and not try and just memorize it, because you're going to always forget formulas unless you understand them. And we go n minus 1. So if we had A of 45, we have negative 23 plus 4 times 44. Because we're not going to the 45 times, we are going 44 because we have our starting point of negative 23. And this is going to be negative 23 plus 4 plus 4 plus 4 plus 4 plus 4 plus 4, 44 times. And that's going to give us, oh boy, I don't know. I have to think about that one. I think the answer is going to end up giving us 153. Ooh, oh cool. Again, if I hold it, it goes straight. Wow, cool. 153. Doink, 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 doink. And also, if they wanted us to make it in an explicit formula, remember how to do that? It would be A of n equals negative 23, and then we distribute plus 4n minus 4. So A of n equals 4n, negative 23 minus 4, minus 27. There we go. We have a little function. Okay, so now we got it, I think. So let's go to number 9, a little bit different. We have the first one. We have the 25th one. We have to find D in this case. Oh boy. So A24. So our formula is thus. A of 25. So A of 25. Let's write it out in a formal way. A of 25 is going to equal the first term plus the difference times 25 minus 1, right? Oh, I skipped 9. We'll go back to that. All right, so we know A of 25. A of 25 is 107. So we have 107 equals 11 plus. Let's distribute so we can, let's go this way. Doesn't matter. We get 25D minus D. Ooh. So we get 107 equals 11 plus 24D. Now we solve. Not bad. We get 96 equals 24D, and D equals 4. So our difference is going to be 4. Cool. Number 11, same thing. I don't think I need, oh, no, they give us D, and we got to find A36. So we have our A of n equals A of 1 plus D times n minus 1. And we know our d is going to be 7. So we can find a of 36 quite easily. A of 36 equals 29 plus 7 times 35. And there we go. We get 274. All right. Let's do number 13. Oh, number 12 looks kind of tricky. Let's actually go back there. Yep, number 12. Let's do it. So we get a of 1 equals 5. A of 18 equals negative 199. We have to find a of 13. So this is a double stepper. So we do this to find d. And then once we find d, we find a of 13. So let's do it. We get a 199, negative 199 equals a of 1 plus whatever d is times 18 minus 1, so 17. So we get negative 2, oh yeah, the straight line, equals 17d, and then we get d equals negative 12. There we go. We got our d. Now to find a of 13, it's pretty easy. So we get a of 13, we don't know what that is, so we get a of 13 equals negative, oh no, let's go back to our original formula. Then we get 5 plus negative 13 times 12. And that is negative 130, not 5, that can't be, 9. Negative 139. Cool, no problem. Number 13 now, here we go. So we have a of n, and we have a of 1, okay, and we have d equals negative 5, right. So let's find n. Okay, so we have a of n, so let's get our formula generalized here. A of 1, negative 5, n minus 1, okay. So we get an a of n, so that's negative 76, negative 21, and we need to find n. So this is going to be negative 5n plus 5. So we're going to end up with negative 76 equals negative 5n plus, not plus, minus 16. So negative 5n equals negative 60. Come on over here. N equals 12. Nice. And we are done. We just need to find n. Woo! All right, let's move that over. Hey! Let's move that over again. Hey! Come on! Hey, what are you doing? Don't. Oh, man. I've been using this too much. It's rebelling. It's in the teenage years. Come on. There we go. I still pay the rent. All right, number 14. All right, same thing. You can do that. Now we're going back to what we did in section 1 a little bit. We're going to do explicit versus recursive. So explicit is just going to be what we just did, except we distribute. So here we go. We have a difference. Oh, I'm still in cut mode. Let's go. Let's change to brown. So we're going up to plus 2, plus 2. So there's our d. d equals 2. a1 equals negative 19. So let's get our formula. A of n equals negative 19 plus 2 n minus 1. And then our explicit comes from that. Explicit just comes from distributing that. So we get a of n equals negative 19 plus 2n minus 2. And then our explicit is going to be 2n minus 21. There we go. Not bad at all. Recursive's quite easy. So we have our a1, that's negative 19. And then our a of n is going to equal whatever the previous one was plus 2. Easy. And then we always have to write n is greater than or equal to 2. Because what if we had a of 1? then we would have to say a of 0 plus 2. And is that possible? We don't know what a of 0 is, so no, we cannot do that. That's why we have to write n is greater than or equal to 2. All right, so for number 16, same idea. You guys got it, I think. Arithmetic means. This is a little bit different, a little bit trickier. So let's do it. So the arithmetic means are the terms between any two non-consecutive terms in an arithmetic sequence. For example, given this sequence right here, the arithmetic means between 8 and 32 are this guy, and this guy. So 14, 20, and 26. Those are our arithmetic means. So for example, we have 50 and 118, and there's 3 means between them. We need to find the indicated arithmetic means for each set of the non-consecutive terms. So what that means is we have our 50, and then we have 3 means, and then we have 118. We need to find these. Oh boy, which means we need to find our D. So here we go. We have our A1, that is 50. We have A5, so 1, 2, 3, 4, 5. Yeah, A5 is 118. Just as we did earlier, we have to find our D. So we get 118 equals 50 plus D times 5 minus 1, 4. That's our 4th term, or 4 terms away. So we get 118 equals 50 plus 4D. Bring that over here. We get 4D equals, 4D equals 60, no, 68? 68. 68 equals 4D, D equals 17. Okay. So if D equals 17, we can find the rest of our means here. So this one is going to be, let's change colors. First one's going to be 67, because we're adding 16. Second one's going to be 67 plus 17, which is going to be 84. Yep, 84, and I'm 101. Getting tired here. All right, so let's cut this guy. And, there we go. All right, number 18, same idea. How many do we got here? I'm going to do 2 more, and then we'll do the application problems, and we'll be done. So we have 5 means. And which one's the hard one? Let's do number 20. So we have 2, 2, 6, 5, and then 4 means 1, 2, 3, 4, and then 3,570. Okay, so this is A1, 2, 3, 4, 5. This is A6. So there's going to be 5 terms between them. So we get 3,570 is going to equal the first term plus whatever D is times how many terms between them. And there's 5 between 6 and 1. That's 5 terms. It's the first term plus the rest. This is the rest. 5 times whatever the difference is. So we get 3,570 equals 5D plus 2,265. So 5D equals 1,305, which means D equals 261. So we have to add 261 to every time. So 2,265 plus 261 is 2,526, and then 2,787, and then 3,048, and then I gotta move this over. Oh no! Let's try again. There we go. And then, oh boy, 3,309. Look at that 3. Poor 3. All right, so there's your answer. Not bad. Okay, number 21. Here's some application problems. These are good. Theater has 35 seats in the first row. 39 seats in the second row, 43 seats in the third row, etc. Write both in explicit and recursive. All right, so left would be explicit, right would be a cursive. Not cursive, recursives. There we go. Let's change to blue. All right. So 35, then 39, then 43. That means our D is 4 and our A1 is 35. So A of n is 35 plus D times n minus 1, which means our explicit is going to be 35 plus, why did I write D? 4, 4n minus 4, which equals 4n plus 31. There is going to be our explicit. And recursive is going to be A1 is 35. And then our AN is going to be AN minus 1 plus 4, where n is greater than or equal to 2. There we go. Not bad. All right. Okay, 22. Ryan weighed himself at the end of each week into his new diet. He weighed at first week 256.3 pounds. Woo! Yeah, Brian. What's his name, Ryan? Yeah, you need a diet, I think. Depends how tall he was. Maybe he was 7'8". Who knows? All right, so at the end of each week, write an explicit rule to find his weight n weeks into his diet. Then find his weight after 16 weeks. So I don't need to do both different ways. It just says explicit. All right. So let's see here. I'm sure it's arithmetic because that's the section. So let's see what the difference is. But first you got to check. Who knows? Yep. The D is going to be negative 1.7. This is negative 1.7. Yep. That's it. So our D is negative 1.7. Our A of 1 is 256.3. There we go. So we can solve this pretty easily then. So our A of n equals 256.3. That's our starting amount, plus our difference, so negative 1.7, times how many terms away from the first. So that is n minus 1. Now, so we need an explicit rule. So we need to actually distribute that. So we get A of n equals 256.3 minus 1.7n plus 1.7. So A of n equals negative 1.7n plus 258. Done. Oh my God. There we go. I can't even write a square or a rectangle around my answer. Come on. All right, last one. On Anna's first birthday, her grandma gave her a check. What color? Dark purple. Anna's first birthday, her grandma gave her a check to open a college savings account. Her grandma continued to send checks on her birthday, each of the same amount. At 7 years old, Anna's grandma had given her a total of $610. Wow. Nice. At 18 years old, Anna's grandma had given her a total of $1,270. How much money did Anna's grandma give her on her first birthday? Good question. So, we need to find what D is. So we have A of 7, and that's 610. We have A of 18, that's 1,270. So we don't have A1 though. How about we just make this A1, and then what would A18 be then? A18 would be A12. There we go. So A1 equals 610, and then we have A18, so 1,270 equals A of 1 plus D times 12 minus 11. So we're using these now. 12 minus 11, which is 12 minus 1, which is 11. So we get D to be 60. All right, so she gets $60 on every birthday. Oh, that's decent. Pretty good. Still nice for her grandma. Wow. So we have A of 7. We know that is 610. A of 6, what's that going to be? 550. A5, 490. A4, 430. A3, 370. A2, 310. A1, 250. So she got $250 on her first birthday, and then $60 more each birthday. Woo, that's nice. That's very good. Grandma's the best. All right, so that's it, guys. Hope that